we really started this company because we want to build the organization that can take humanity from humans in the loop for design and manufacturing to humans out of the loop. How do you have a system where a human being can say, I want to make a new medical device, or I want to make a drug delivery system, or I want to make a new kind of battery, and then have a computer design that thing, manufacture it, and ship it to the end user.
Welcome to Research Radio, the official podcast of Contrary Research. Contrary Research is the best starting place to understand any private tech company. In each episode, we'll dive deep into the most important conversations and companies in technology. I'm your host, Kyle Harrison, General Partner at Contrary. For more info and to read our full reports, you can check out research.contrary.com. Myself, guests, and Contrary may hold financial positions in the companies discussed. This podcast is for informational purposes only and should not be used for investment advice. People have been talking about software eating the world since 2011, but it turns out there are a lot of things in the physical world that aren't that easy to eat. Pretty quickly, software ate the majority of low-hanging fruit use cases like workflows and existing digital processes. But what happens when you're trying to wrap software around a thing that happens 100% in the physical world? Driving, shipping, building, flying. Those are much harder things for software to take on. Over the last few years, we've seen more companies build at the intersection of bits and atoms, companies like SpaceX and Anduril. These types of companies need to understand the context of the physical world in order to build software and automation around it. Companies like Anduril, for example, have built hardware products like drones and sensors to capture the necessary data. But what about the $14 trillion of products that we're manufacturing worldwide, from clothing to electronics to cars and everything in between? The data required to automate quality control and eventually manufacturing itself doesn't exist online. It's in people's heads and literally woven into the products that they manufacture. To drill into a quality issue on any given product, you might have people literally sawing open a Vision Pro to figure out some specific issue. Lumafield is trying to change that by building the world's best database of manufactured objects. Getting the data in the system is the first step towards automating manufacturing in the direction of taking humans out of the loop as much as possible. Here's my conversation with Eduardo Torrealba, the CEO and co-founder of Lumafield. Well, Eduardo, thank you so much for doing this. I'm super excited to get to dig in.
Yeah.
I thought first where we could start is really kind of first lay out the kind of point A to Z. Where are we today?
Yeah.
What's the vision?
Right.
And then we can kind of unpack each of the individual pieces.
Yeah.
So the first thing is really just, what are you building at Lumafield? Why is it so important today?
That's right. Yeah, I think in the A to Z analogy, we might be on step B. So very, very beginning of Lumafield. But yeah, we've been building a company, I think in a little bit under the radar for a few years now. I'm really excited to talk a little bit more about the long-term vision and where we're going and why we started the company with you today. So Lumafield was founded back in 2019 by myself and a group of co-founders. And we really started this company because we want to build the organization that can take humanity from humans in the loop for design and manufacturing to humans out of the loop. It's a pretty big vision. It's not a thing that we talk about a lot at Lumafield, but that's where we're going. That's the step Z. Is how do you have a system where a human being can say, I want to make a new medical device, or I want to make a drug delivery system, or I want to make a new kind of battery, and then have a computer design that thing, manufacture it, and ship it to the end user. And we believe that the things that hold us back from getting there are either manufacturing problems or design problems. And so at Lumafield, we're building the world's best data of manufactured objects and tying that back to the design intent of those objects, and creating a system where manufacturers can actually close that loop for the very first time. So that's where we're going. Big vision, and not the sort of thing that maybe you hear every single day. We've gone about it from a very, very specific way. So yeah, just excited about what we're building here at Lumafield.
Yeah. Walk me through so in terms of where you are today, starting with industrial CT, why was that the entry point, the wedge that made sense, and how does that inform the vision going forward?
Yeah, so back in 2019, when we were talking about co-founding the company, myself, Andreas Bastian, we were talking a lot about this idea that problems in manufacturing and with designed objects, they either come from design issues or manufacturing issues. And it's one of those two things. And it really, you boil it down a lot. But, I've been working at Formlabs on 3D printing, which is really on the how do you make something manufacturing in the spectrum. And Andreas was working at Autodesk, working on generative design for Autodesk Fusion 360. And so we both knew that there was some gaps that you really couldn't solve independently. You couldn't perfect design without understanding manufacturing, and you couldn't get manufacturing without understanding the design intent. And so we wanted to link those two things together in a way. And in 2019, you're kind of starting to see the beginning of the takeoff of transformer-based artificial intelligence. OpenAI was out there, ChatGPT hadn't launched. There were a lot of really interesting things you could do with neural networks, and we thought, okay, if this takes off the way we think it's going to, these AI models will ultimately need, really high quality data to be able to make these decisions. An AI model is not going to be able to design something if it doesn't understand, all of the world's design knowledge. And that's not information that's available on the open internet. It's not going to be able to manufacture something if it doesn't understand all of the world's manufacturing knowledge. Another thing that's not available on the open internet. So we wanted to build a company where we could be the source of truth of data for all of manufacturing. And we're not going to get there by saying that's step one, right? You can't say go 0 to Z, at least not in this world of manufacturing. So we wanted to build something that was so valuable and so transformative for our customers that it was undeniable that they had to buy our technology to really revolutionize the way they were working. So we looked at the landscape of all the things you could do in manufacturing, and we said the best quality data that you could possibly generate in manufacturing are CT scans. How do we make CT scanning 21st century technology instead of having it be based in the same methods, the same processes that have been there since the 60s and the 70s when the technology was kind of first birthed. So that was the idea. How do we create this data that's transformative that people see and they say, I have to have that. We make it affordable, make it easy to use. We embed it into your everyday process as an engineer, as a manufacturing organization, and then use that to create that nucleation point for all of your other design and manufacturing data that you could possibly generate as a company.
So, and that's a really good segue into, let's take a step back into the underlying technology itself. So obviously, like you said, CT scans have been around for a long time. Even the underlying science is pretty old, right? And so you kind of trace that through. And I've heard you say in the past that, sometimes when you look at some of these CT scanners from like 2005, they can be very similar to ones today. But there is also this cutting edge where they're getting to deeper and deeper levels of specificity and things like that. Yeah. So there is this sort of cutting edge. How do you think about the technological progress of this sort of scanning discipline, and how are you guys pushing that forward? Yeah,
I think that CT scanning has mostly been pursued as a scientific instrument. It's viewed in the same way that, a spectrometer might be viewed. The kind of thing that you need a really highly trained expert to operate, and not just to operate, but to actually interpret the results. In most quality assurance labs that have a CT scanner, there's this idea of these like level 1, level 2, level 3, these trained technicians that have maybe the equivalent of a master's or even a PhD in training in order to understand the data and say, yes, this part is good because I ran the scan correctly and I interpreted the data correctly. That is a huge barrier. It's very, very hard to scale a system that requires that level of expertise. But we know that most people that need the data, they don't actually need that level of, not everything is an implant or a jet turbine engine blade. There's a lot of things, your phone, your watch, batteries, medical devices that are maybe consumables. These things have, they're important if they fail, but it's not quite the same as if a jet engine explodes in flight. So can we lower the barrier to using the technology to make it more accessible, to make it a thing that people have as a go-to? So we really looked at the entire thing. There's really there's the actual scanner itself. There's the fundamental technology that acquires the images. And then there's all the electronics, the compute, the software. And we decided we wanted to be vertically integrated. We wanted to design our own scanners. We wanted to build our own X-ray detection technology. We wanted to run our own factory. We wanted to build our own software from scratch. We really don't buy very many things at all, especially no software comes off the shelf. This is totally custom, vertically integrated end to end. It's a very, very unique approach to take to this industry. And it's allowed us to make innovations happen that are just not possible with the other people in that space.
Well, you described the sort of limitations, right? The skill base and there's also this cost element, right? Where you look at the people that do have industrial CT scanners, and there are hundreds of thousands of dollars, if not millions of dollars. So even large organizations that do have them, they probably have very few of them. And then there's this massive long tail of people that don't have them, right? So how do you think about stepping into that status quo? Is it, and I know there are these, if I get the names right, I think it's Nikon Metrology and Zeiss and those folks, like, are they serving this sort of higher end and you're enabling the long tail, or how do you fit into that status quo?
Yeah, totally. I have nothing but respect for Zeiss, Nikon, Northstar Imaging. There's some really great companies that build what I think of as like the cutting edge that humanity is capable of in this space. They have amazing X-ray detection technology, phenomenal X-ray sources. They're these really exquisite systems. But you don't need a Ferrari to drive to the corner to get a gallon of milk. And so we're trying to build the Honda Civic of CT scanning that just hasn't existed before. And one of the sneaky things about CT scanning that makes it so expensive, it's actually not just the upfront cost, right? If you wanted to go buy an airplane, maybe you could pull together the cash to buy an airplane. Then you've got hangar fees and maintenance and service and inspection. And if you don't get your airplane serviced every year, it's basically worthless, right? Because who knows if it's going to work or not. CT scanners are basically the same. You have to have ongoing maintenance, ongoing support. You have to pay this money every single year to keep the thing running, to keep the thing maintained. Because if you end up not using it anymore, and you want to sell it and you don't have these maintenance records, it's basically worthless. So your $2 million in CapEx goes to zero immediately. There's some real challenges here. So your total cost of ownership actually ends up being, over $100,000 a year on top of maybe $1 million, $2 million CapEx, plus the salary of the person operating it. So yeah, even if you have a couple $1 million lying around in your manufacturing organization, you might not have another $250,000 a year in your budget to run the system because it requires so many different pieces. So we get rid of all of that. We give you the hardware, we give you the software, we maintain the systems ourselves, we provide the warranty, the training, everything you need, one-stop shop, starts at $75,000 a year. So you don't have to pay upfront for the scanner, and you get more than you would ever get from any other organization for a fraction of the cost. And any engineer at your company can operate the system. We even have people that just have interns or technicians that have lots of other jobs that walk up and run scans on our system. So we've really, really lowered the barrier, not just to access the technology and acquire it, but to operate it and to actually get real information out of it.
When you look at the descriptions of what the status quo is for those people that couldn't afford it before, It's like I've heard these stories of people literally sawing open some of their products to figure out what's going on inside and stuff. Do you think that this moment in time, when you think about the sort of why now, is it largely that there's always been a why now? People have always wanted to be able to have this capability. It's just because of these limitations you're talking about. Or is there something unique where it's like, we're manufacturing more things, or quality control is more important than ever? Like, how do you think about the current moment in time?
Yeah, probably I should have some story about onshoring and global trade routes and supply chains and, all that stuff is true. But ultimately, we never stopped making things in the United States. We never stopped making things in countries with expensive labor. And those are usually higher cost items that have, higher quality control expectations in them. And so you need skilled labor. I think that maybe there's a story about the generational shift happening where a lot of the quality engineers in the United States are kind of aging out. You hear that in a bunch of places in manufacturing. But at the end of the day, this is a process that's been the same for a long time. You make something and you make enough of it. It's actually the amount of stuff that you've made is what makes you better. It's not the number of years that you've been in the industry. It's the amount of experience that you have by making things. And that takes a lot of time in the world that we're in now. And so for an organization making a water meter or a battery or a medical device, a new grad just hasn't had the experience of making enough of those things. And so you end up with these people that have been in their careers for 30, 40 years. And they're the only ones that really know all the intricacies of how to design and manufacture these things. And there's no big change there, right? There's always been why is this thing not working? Factories are just an engine of entropy. If you just have a factory working perfectly and you walk away from it, it's going to break in some amount of time. Yeah. Maybe that's weeks, maybe that's months, maybe that's hours. But you need these people that are kind of tendering manufacturing. And so if we want to go faster, if we want to do more, if we want to grow, and we do want to grow our economy here in the United States, we need to be able to do more of this. We need more efficiency, we need more excellence. And so I think there's always an appetite for that, which is, I think, the reason that you see, a large number of publicly traded companies, Fortune 500s, buying our systems. We have, 85% of the customers that we have never had a CT scanner before. And they're big names. I can't say all of them in a podcast like this. Some of their logos are on our website. But these are organizations that are cutting edge in their field, but they haven't been able to justify the cost of a CT scanner for one of their 100 facilities. Now we're unlocking that for them. So I think in many ways it's just this different approach to the problem of quality control and information and data than what that industry has seen before. That's the real game changer. It's just that we came in and said, what does modern technology allow us to do? What does a hardware software combined system allow us to accomplish? Most of the companies in this space are giant multinationals. They're not very good at building software. We're really good at building software at Lumafield.
Yeah, I love that idea. It's really interesting too. I mean, you think about the sort of what's Lindy, right? The things that have stuck around for a long time. And it's like these companies that are massive, they don't stay massive because they're lumbering and sleepy and whatever. Sure. It's like they stay massive because they're good at what they do. Yeah. And so the fact for you to be able to say like, well, I mean, people would have loved to have had this even in the 60s and 70s and 80s, whatever. Like the problem has always been there. We're taking that cutting edge and bringing it down to everybody can have it.
Yeah.
And so it's a good segue into, let's talk about the product, kind of unpack the pieces of it. So I think buckets I think about it is sort of the hardware, software, AI as a key component of that. And I think on the scanner side, you've got Triton and Neptune, Voyager on the software side, Atlas on the AI side. There's a lot of adventurous maritime themes in there. Well, maybe tell us that kind of the history first of like, how do you think about those things? And then maybe we start with the scanners and work our way down. How do they differentiate, stuff like that?
Yeah, I think I would actually start with Atlas first. I think that the long-term vision here is that you have this this system that has seen a lot of manufactured objects. What if your company could hire the best manufacturing manufacturing engineer in the world, come into your facility and tell you all the ways that you can improve
like building
production.
The brain.
Yeah, right. It's this brain that has been exposed to everything your company has ever done, right? We certainly don't take like a competitor's data and then give it to someone else. We have 2 companies that make running shoes. We're not mixing those, right? But you could put all of your company's data into Atlas, all of your experience, that brain of we running into this problem, bringing up a new product in Malaysia. Okay, we actually had that same problem in Vietnam. You can translate it over directly, and it doesn't have to be that one engineer as the bottleneck between those 2 things. How do we build the corpus of manufacturing knowledge for your organization that allows you to have the best manufacturing engineer in the world on staff at all times, 24/7 globally? That's the vision of what Atlas will become. It's not that today. We certainly don't market it that way. We don't position it as that.
It goes back to the vision though of like this is what we're trying to enable.
Right, but we believe that Atlas needs to be fed information and data, and so that's where we zoom back to the hardware. So we wanted to build a very differentiated hardware product that was easy to use, easy to make, affordable, and sort of the hallmarks of the kind of go-to systems that just get like used and abused in manufacturing facilities. That was not a scientific instrument. And so we started with, what are the pieces of a CT scanner that fail most frequently? What are the pieces that have to be replaced? What are the pieces that have to be maintained? What are the things that are, maybe the cost per, equivalent performance is kind of outside of what we think it could be if we re-engineered that product? What are the things that you optimize for in a CT scanner traditionally that maybe a manufacturing environment doesn't care about as much? We did a lot of customer research. We talked to a bunch of people. I spend about 1 day a week with a customer somewhere in the United States right now. So I see a lot of these facilities. I've been doing that for a long time. So we designed the hardware to be the kind of thing that you would put into a quality lab in a factory, right? It's going to live next to equipment from Keyence or from Instron, these big scientific instrument manufacturing quality assurance companies that sell massive numbers of their units because they just provide absolutely vital information to their customers. And they do billions of dollars in revenue off of those product lines. So that's what Neptune is. Neptune is the CT scanner for the quality lab in a factory. Never been built before. Then we view Triton as kind of the next step, right? Triton is actually, the core of a Triton is a Neptune with a part exchange, automated system on top of it so that you can put it into your line. You can scan everything that you're making, depending on the quantities of things that you're making. You're able to load and unload automatically. A lot of factories, their quality assurance process involves some level of batch sampling. And you care a lot of times less about whether or not an individual item is good. You care more about is the trend line of all the things that I'm making, right? Let's say you're bottling beer. Every single individual beer can doesn't have to be checked. But if you check every 100 or 1,000 or million, you could actually see a trend that like, oh, actually we're going out of nominal here. Like we know that this production line is starting to have a problem. We want to preventatively stop that from happening. That's what Triton is for. It's a sampling system. Some things it'll be 100%, some things it'll be 10%. It'll provide you enough data to control that entropy that's trying to keep your factory alive. So that's Triton. Triton's a larger volume data, processing endpoint for your factory. And then, Voyager is kind of the middle point, right? Voyager is the place that the data shows up. It's the place that you're able to examine individual scans, but also aggregated scan data. It's the place you interact with Atlas. It's kind of the focal point for the entire ecosystem. And because it's cloud-based, anybody in your entire value stream can access that if you give them, that permission. So if you're making, a complicated optics assembly and you have parts coming from 3 different countries and you're doing the assembly in your facility, and you scan that and you say, oh, this is out of alignment. Well, this part here and this part here, they're actually out of spec. We can see that through this imaging that we're doing. You can show that, the phrase our customers use is smoking gun. They can send somebody a scan and say like, hey, this part's off. And somebody in the other side of the planet can look at that, interact with that software in real time, and change the process and fix that problem very quickly. It happens all the time.
Yeah. So unpacking a couple of the pieces, because one of the things also I've read a little bit about on the scanner side is that even trying to again, kind of lower the barrier of the skills required to operate the scanner is an important piece. So this sort of auto scanning capability where you don't need to know exactly how to place it or how to do it, kind of auto adjust and stuff.
That's right.
How much do you think that is? I mean, is that ideally completely remove any skill from the scanning process so that literally, you think you said, interns can come do it or whatever?
That's right. Yeah. So, artificial intelligence is another piece that we integrate across that entire stack. Atlas is the most, it's 100% AI, right?
Yeah.
But Neptune is not 0% AI. There's actually a lot of software that runs on Neptune that's been trained using artificial intelligence to make sure that the auto scan settings are really high quality. So we were able to have someone put an object in, answer a couple of quick questions on the touch screen. You press go, and it optimizes all of your system settings, X-ray source, your X-ray detector, scan time, everything that goes into there. It's a multivariable, nonlinear equation that you have to optimize to get a good quality scan. And it turns out computers are really good at that if you train them.
Sure.
Humans are okay at it, depending on the human. I'm probably worse at it than most people. But we make it so that if you can use a microwave, you can probably use a Neptune. And depending on the settings on the microwave, that might be a little harder actually than the Neptune. But we give people that next layer down, right? If you want to go into manual scan settings and dig all the way in and adjust everything yourself, that's available to you too. So we're not going to stop experts from being experts or people from becoming experts, but we're not going to require that as step one. I think that's the big shift. I'm sure the cameras, that are filming us right now, they're probably not all running on auto mode, right? The guys here, the film crew, they know what they're doing. But they shouldn't have to be experts to use a camera. You should have that auto mode available to people. That's what we've created for CT scanning for the very first time. Never existed before us.
Yeah, totally. Well, and then you take a step down into the software side on Voyager, and one of the other things that is interesting is that, if I understand correctly, that it's while you can take all of the scan data that you're getting from your guys' scanners, there's also the ability to take scans from other scanners, 3D scanners, whatever it is, bring everything together into one place.
Yeah.
I'm curious how much of that is, if you were to think about your customer sort of data set, how much of that is coming from external scanners versus most people, it's just all coming through the sort of Lumafield value chain.
Yeah, it's probably less than 0.5% of the data is coming from third-party stuff. We built those, those integrations, those products, that upload capability. We're pretty big believers in customer-driven product development at Lumafield. And so we install systems and we get people using our software and we go visit them in, die casting facility for automotive, and they have a bunch of 3D scanners sitting there and they tell me, I love your scanner. Your software is amazing. I really wish it was available for this product. And I'm like, we could do that. So our software team, they run a 2-week sprint. They release the ability to upload other types of 3D data. Boom, that customer is uploading the data into our system. We still, our sales team focuses on getting Neptunes and Tritons in the field. And then the other software capabilities we think of as, they're places to bring that data. When I talk about training that manufacturing engineer that knows everything about manufacturing, that's going to ultimately have more sources of data than just the products we build ourselves. But we think that if you want to capture all the data from a factory, there has to be some compelling reason that you're the endpoint, that you're not the API feeding into the endpoint. We believe that that's the unique quality of data that we bring to the table with CT scanning. We think that's going to be the thing that creates that gravitational pull of other types of data, whether that's other CT scans. That's it's a pretty small market. We're not too worried about that. But 3D scans, 2D imagery is something our customers are asking us to add, the ability to just import 2D images from the cameras in their facility. They want all that to live alongside a CT scan of the object. There's no end to where that, the kind of data that we could ingest to train that manufacturing engineering, artificial intelligence. But we want to be the ones that train it. We don't want to be the ones that feed into somebody else's data.
Yeah. It also speaks to, when you talk about the accessibility piece, the fact that most of these people don't have a ton of other ways to get those sources of data. And so you've really made that accessible for the first time.
Yeah.
And the second thing is that the value chain being truly vertically integrated is that people are sort of thinking why would I be pulling in all these random systems when I can have one sort of sleek process?
That's right. Yeah. We have a lot of customers who have, brought us in to replace multiple other steps that they do in their quality assurance program internally. They might have 4 or 5 different measurements that they take where they measure something and then they cut something in half and they measure something else and then they cut it another way and they measure that. we can eliminate all of that. We can do what we call software-defined inspection. So it's this idea that you do one scan, one time, and you have all of the data you could possibly need that you could ask questions to. And then you can use Voyager to run that analysis at scale across all the information you've ever had. So if you're scanning every single thing you make in a factory, or 10% of everything you make in a factory, and you run into a quality assurance problem, and you didn't inspect that exact thing in the original batch, you can actually just create that analysis recipe, run that on your entire data set, and you can chart that statistically and say, okay, the problem actually only showed up in this range of time. We don't need to issue a full recall. We just need to go find these 37 items that are tied back to serial numbers in the system. So you scan once, and then you apply every single kind of measurement that you want. This isn't true in traditional measurement techniques. If you take a picture and you don't have the right angle on that, you never know what was there. You run something through a coordinate measuring machine, you run your touch probe, you hit all the points you care about. If you don't hit the point where the problem is, you're never going to know if you had a problem there. 3D scans, they're going to get the surface, they're not going to get the inside. We give you all of that information in one go, down to the voxel level. And you can get whatever information you want out of that. So it really changes the paradigm of the way that people think about quality assurance and asking questions about their manufacturing processes.
Yeah. How do you address the sort of complexity of, you have a lot of different types of customers, right? You talked about automotive, medical devices, electronics, whatever it might be. Every device is going to have a little bit different, shape and structure and things that they care the most about. When you're trying to build automation into the system as much as possible, how do you adjust for so many different end cases? Yeah,
we really, we apply kind of two approaches. The first one is what I said earlier, which is customer-driven product development. We had paying customers while we were in stealth mode that were giving us feedback on the quality of the scans to fine-tune what Neptune needed to be. And so we wouldn't build a feature without showing it to someone already paying us money. And they would tell us, that's great, or I don't need that at all, right? And so I think that's really focused us on what we build. The other one is this really 80-20 principle of we want to build, the 20% of features that cover 80% of the use cases. And so you're right that a medical device and a running shoe and a die-cast part for automotive, wildly different. But you might care a lot about porosity in all of those things, right? Are there any voids in the plastic or the foam or the metal? We can build a porosity toolkit. We can build an inclusions toolkit. Is there anything in there that shouldn't be in there? And that is generalizable across industries. So in the 2 years since we launched, we've never actually built an industry-specific workflow or technique until just now, when we just launched the battery analysis capability. And that's one that's being driven by a ton of customers who are making batteries, inspecting problems in batteries, and saying, we really want to be able to run these specific measurements that, again, they work across enough different kinds of batteries that we can build that generalizable toolkit. We don't build super custom one-off solutions for customers. We're not a consulting business. We're building the thing that changes the game for as many customers as possible, as many industries as possible. So that's the approach we take for product development.
Yeah. Well, and that is a really interesting funnel into AI. So I want to unpack a couple of the pieces of how you think about AI. Before we move on from this sort of automation conversation, I also wanted to kind of dive in a little bit how you think about the skills component, because one of the things that's really compelling for folks is that you are sort of removing the necessity for the skills. It's not sort of eliminating the experts. But I heard you tell a story once where you went to visit one of your customers and they had a room with 4 people who were literally just in there. Their only job was just taking stuff apart and figuring out if there's any issues with it or whatever. Do those people entirely go away? Do they go do something else? How do you think about, because I also think about it technology often creates new skills, right? You think about the role of a prompt engineer that didn't really exist until LLMs got popularized. Right. How do you think about the skills or capabilities that are kind of getting created by people using your products?
I think my hot take is I don't really think about that. The labor market is constantly shifting. It's moving faster than I'm going to be able to wrap my head around. And my job is not to design workforce training programs. That's a state level thing to think about, right? Or a very large organizational thing. My job at Lumafield is to build the best technology I can that solves pressing problems that the best companies in the world need to solve for us. And if that's something that involves, upskilling labor, great. We're happy to build training programs and go in there and teach people how to use our system. But I actually think it's more important that we think more about what's the best thing for humanity in the long run. And in my mind, there's one dividing line. It's not industry 1.0 or 2.0, or I don't even know what number we're on now, probably 6 or 7. Try to avoid the conferences. I think there's just a line, and it's humans in the loop, humans out of the loop. There are a lot of things in factories that are automated that used to involve a human being, and now they don't. They involve a giant, massive press. They involve, computer-controlled milling machine. That used to be a person there with a bunch of dials. Now a computer does that. That job was eliminated, but the quality of those components is significantly better. So our goal at Lumafield is to move humanity from humans in the loop on both design and manufacturing to humans out of the loop. We really want you to be able to walk up to a system and say, I need a new medical device to deliver this drug. Here's the fluid properties of this drug. We want a system that can design that for you and then know where to manufacture it, put it in boxes and ship it to the end users. And we don't want any human beings to touch that thing because we think that's the process to move the fastest. If we can close those loops and get it right the first time, that's transformative. In the meantime, humans are still involved, so we'll deal with them. But my goal is not to build work-based training programs or to build a brand new skill set. I think if you would ask, people that are working on LLMs, what do you think about the elimination of jobs and the new job creation? That's the popular thing to say. It's like, oh, it creates new opportunities. But that might be true, that might not be true. I don't really know. But I know that the economy's grown, it's gotten better. There's more opportunities for humanity. I think as we automate more things, we put those in the hands of computers, we create more opportunity for human flourishing. That's what we're doing at Lumafield.
I think what's really interesting about that is that's actually reflected too in how you almost took my framework. Because I think I'm like a lot of people where the framework that I used to think about your product was what can I really touch, right? With the scanners, I can look and feel, and
Sure.
That's a thing. And then it's what can I kind of touch? And it's the software, at least I can click around in
Sure.
it, and the AI is more amorphous or whatever.
Yeah.
You kind of flip it around and say, well, hey, we think about it this sort of Atlas first.
Yeah.
And then we're thinking about how do we take the physical world
Yeah.
and bring the data that is out there,
Yeah.
but that is nowhere in the sort of system to be able to build
That's right.
some of this automation. I feel like it's the same concept, is that it's not a question of, well, how do you take the physical world and rearrange it?
Yeah.
It's how do you take the physical world and extract the data you need to be able to do
Right.
this more effectively?
Yeah, I mean, I think that the ability, as I said before, of an engineer to know how to make the right decisions is not a function of how many years they've been doing a job. It's how many times they've done something. If you've done something 100,000 times, you kind of know all the different failure modes. And so, we really don't want to reinvent injection molding or die casting or blow molding or any of these things. These technologies work really, really well. I think that honestly is the downfall of 3D printing. There's been this desire to replace incredibly high performance, very economical solutions for rearranging the physical world into the products that we care about. If we can bring the digital capabilities of the software that we're building, AI that we're building, we can attach that to the best manufacturing systems on the planet. That's where the power comes from, not from building our own factory. That you're never going to build a factory that actually covers the range of things that humanity needs to produce. Way too much stuff. There are people that are really good at that. How do we bring them superpowers? How do we bring the manufacturing engineering level that you get at an Apple or at a Stryker or at a Lockheed Martin? How do you bring that to every company on the planet? That's what we want to do.
Yeah. So let's talk about some of the different pieces in the AI equation, how you guys think about it. So a couple of things I've heard you talk about. Number one is this idea a little bit of, each of these customers want to help them almost build their specialized brain. It's their data,
sure.
right? And when you think about these general purpose models that have everything from, Roman history to U.S. economics or whatever, there's bound to be hallucinations and issues.
Sure.
That you guys want to solve for that. I'm sure there's some training and fine tuning on the exact data you guys are creating.
Right.
At the same time, I've heard you talk about we're not trying to be an AI model company spending billions of dollars custom training our own models.
Right.
So where do you draw the line? Is it a specific model that you're trying to fine tune, or have you thought about that?
Yeah, for sure. So there's no secret that we're using off-the-shelf different LLMs. Atlas is referencing a few different ones. We are constantly evaluating at what point in that conversation should we be grabbing different kinds of LLMs. It's essentially an agent, right? There's nothing crazy about that approach. And then we have our own data store of information that we've fed into Atlas, and then our customers' data. So there's kind of this where do you pick the right LLM for those different points in the conversation? Then what data stores are you referencing to bring up the answer to that question? And then what data from the customer are you bringing to that overall conversation? So, we're training these things, we're improving them. But today people use Atlas to ask questions about CT scanning. The most common conversational thread is, I've scanned a part and I want to be able to measure a rotational slice plane through this thing. What do I need to do in Voyager? An analysis, like these are all the different steps that you need to go through and the buttons you need to click. And it's basically like a tool tips for running a CT scanner and analyzing the data, right? It's like having a really great engineer who knows how to use that system, like sitting there next to you and guiding you through it. It's not the co-pilot for all of manufacturing today, right? That's where it's going. That's the future of it. And I think that as we grow in that direction, there will be a world where we have to do more custom training, where we have to build, more guardrails around that system. But today, we're explicitly not telling our customers, you need to go out there and ask it how to manufacture your device. You can do that, but there's no guarantees that that's going to be perfect. And I think building towards that system requires a lot more energy and data than we have today. But I think we're going to be the ones that get there first because of the quantity of data that we're producing.
Well, it feels like when you look at the use cases of AI, a couple of them we've touched on. There's things like the data acquisition piece, right? So that sort of auto scanning in the scanners, that's right. A component of it, right? You're leveraging AI to make it easier to get the data in. There's the reconstructing where it's like the image is going to be much higher quality. It's much more engaging because of the technology we're using. The thing I think is most compelling is sort of what you hinted at there, which is this future state of talking about effectively enabling Atlas to help customers make go, no-go decisions.
Right.
Actually, walk me through how you think about that. Like if it's not today, if it's at some point, but what would that actually look like of these things basically saying, hey, we've looked at this, there's an issue, let us go do the things that we should to make it better.
So I think, there's kind of that long-term, A to Z vision, which is like no humans in the loop, a bunch of robots and AI making everything for humanity, orbital space factories running on a Lumafield operating system. Totally crazy science fiction stuff.
Yeah.
I think it's going to happen in my lifetime.
Yeah. I'm here for it.
Today, the decision that we made that I think is actually fairly unique is that we wanted to build products that would provide undeniable value on day one that would drive economic activity and sales of our products into our customers. I think the thing you see with a lot of people who approach this space is they say, we're going to build the total solution for everything all at once. And you end up hitting the entirety of the long tail of all manufactured objects immediately, and it just falls apart. This is a problem in CAD. When people are like, I'm building a new CAD tool. That's great, but until you have sheet metal, it doesn't matter, right? Until you can do all the things you would need to do for an organization, you can't have 80% complete CAD tools. You need 100% complete CAD tools. And so we don't want to build the 80% complete manufacturing automation system. We want to build this very specific, valuable piece that's a building block to continue going from there. So in the long term, it's not just CT scanners, right? It's a system, it's a factory that has machines that are making things, and then all the inputs. So let's take injection molding, for example. The exact material you're using, the temperatures that you're setting your injection molding press to, the pressure, flow rate, temperature of all your cooling liquids, the dwell time, everything that goes into creating that part is feeding into, Lumafield. After you make the part, it gets spit out, it runs through some sort of inspection process. It's Lumafield hardware. That data is then going back into, the Lumafield operating system for your factory. And then we're saying, okay, here's all the inputs, here's all the outputs. Where's the differences? How do we attune those different parameters based on everything we've seen in the past? If dimensional, measurement is drifting out of what we want it to be, or you're getting some warpage, or you're getting some sink, or you're getting some, some inclusions, some voids. From everything we've ever scanned, what do we know fixes that problem? Let's turn that dial, right? Let's tune that thing. Let's change the temperature let's change the dwell time for your part. Let's change the flow rate for your cooling liquid. And then we will see how that works, and we'll close that loop continuously. And then the parts will be spit out, and they'll be good. And you'll be able to reach that point much faster than you have to today. And so over time, we'll be able to say, okay, we've scanned everything your company has ever made. We've looked at it all, tuning all the parameters, and here is a design for something. Is this going to work? We can actually run that and say, what's this most similar to? Where the problems we can predict? Okay, this line is going to need to have longer dwell time than normal because there's a thicker section of this part than what it's typically used to dealing with. We can come up with this preemptive manufacturing process to tune all the parameters on a production production facility, an injection molding press. You could get first-time right manufacturing. It's never been done before. And I think we're the first people that are actually building the tools that can make that possible.
Yeah. Well, and talking about some of those tools, we've touched on a few different pieces, right? You mentioned that there are, on the AI side, there's a few off-the-shelf LLMs you can use, but all of your software is custom, and you've built a lot of that.
Yeah.
You also have a manufacturing facility we're going to show off in this video. Maybe tell me a little bit about your own in-house manufacturing. How have you thought about that? Is it also building a lot of your own custom components? Are there other partners you're working with for that? Or
Yeah, so when we, as I said before, we kind of like thinking about what's the best manufacturing data you can produce, it's CT scanning. Okay, how do you reinvent a CT scanner for the 21st century? We really looked at, of all the components that are there, how are they typically designed? Usually CT scanners are really more like kit cars. They're kind of bringing different components from different suppliers and sort of putting those together, and then wrapping it in a big lead box so nobody gets cancer. We said, okay, what can we do to design all these pieces to make them less expensive? How can we use software to make control better? You don't need giant granite blocks if you have like well-calibrated motion systems. So we kind of approached it from that perspective. And then as we were getting to the end of that design, we started saying like, okay, the norm here is that you would go to a contract manufacturer and you would give them your design and maybe start building things. And we've done this enough in our careers building hardware that we know that the on-ramp to go from, your signed contract to having a good unit that you can ship to a customer can be 6-12 months with most CMs. But we thought we could do that faster. And so we decided we would build our own factory, especially in, 2020, 2021, COVID, how do you get into the facility? You really need, it's like I said before, it's not the time, it's the amount of things that you've built. So at this point, we're building more CT scanners, of our design of Neptune, than anybody else in the world is building of any single model of a CT scanner. So we have way more reps than anybody else, and we wanted to have that be our own competitive advantage. So we decided to vertically integrate. We found a facility, we signed a lease. I think it was 70 days later, we shipped a unit to a customer.
Wow.
So empty box to fully built out factory, fully built unit, like production quality in the hands of a customer. I've never seen anything happen that quickly for hardware. And that factory, continues to produce substantial volume for us. And I think over time, I get questions like, when are we going to move to a CM? I basically say like, probably never. We're achieving 70+% gross margin with the way that we're operating the business right now.
Wow.
So, how much better does that really need to be? If I need to get to 74%, that'd be great, but there's actually things I can do on software to increase my margins. So I have a lot of control over my entire supply chain. We really only buy, one thing, it's X-ray sources from traditional vendors in the space because they're good at that and those work, and there's a lot of security applications, and we can have a supply chain for that that's, domestic and differentiated and doesn't depend on, sort of Chinese government allowing us to get things. But everything else, our motion systems, our X-ray detection technology that we invented ourselves, all of that is a bespoke supply chain of, more commodity vendors where we can swap things out if we need to. That's pretty unusual for the space that we're in.
Anything you're willing to share too, diving a little deeper into that of like, so I know that it's, I think starting at $75,000 for the scanner. Yeah. There's obviously also the software and there's other capabilities that people can have and stuff like, how do you think about the pricing and how do you achieve those kind of margins when you are out building your own boxes and doing all this stuff?
Yeah. So we, we think that, we want to create a lot more value for our customers than we capture. Because I believe that, the more value you create for the customer, the stronger the relationship is, the longer that's going to last. We really don't have a lot of interest in like nickel and diming our customers. But I also think businesses need to make a profit and they need to be efficient and do well. And so, we really looked at how do we provide a ton of value and then how do we make ourselves as efficient as possible. We priced the system based on some of the value that we're creating for the customer, not just on the cost that it takes us to build a system. I think a lot of the traditional hardware world is kind of built on these multipliers. And because we run on a recurring revenue business model, because the system is half in your factory and half in the cloud, it's a little bit squishier than that. We've got to build that value at a lot of different places. Every time you run a reconstruction model, we spin up cloud resources to do the reconstruction and we run GPUs and there's cost associated with that. So we want to align our customers, the way that they're paying us with the way that we're providing value. We want to be able to bring new software features to market very quickly. We don't want to push an annual update. We want to push an every 2-week update, which is what we do in our software organization. So we move faster, we iterate more quickly. I think the idea around pricing is if we're working with a customer who's building, I talked about beer cans earlier, I think, their pricing model that they need to pay might be different if they have Tritons across 20, 30 locations globally. That might be different than a small, medium-sized business that's getting a couple of Neptunes for 2 facilities in the United States. So we want to be able to price that based on the value that we're creating for the customer, make sure that we're giving them a lot of value, also that we're capturing some of that. So I can tell you I have systems where the contract is $75,000 a year for that system. I have a system that's $300,000 a year. And the main difference there is the software and the analysis and the value that we're providing. There's some hardware shifts as well, but there's not a huge degree of difference in kind of what we build on our side. In the same way that a lot of electric vehicles, or even a lot of computer processors, they're kind of software capabilities that you can pay for that increase the performance. But if you don't need that, you can dial that back. You can get a less expensive version of that thing that makes it accessible to a lot more people. That's the way we think about pricing at Lumafield.
So as you're trying to balance that value creation and value capture equation, any North Star metrics that you would point to and maybe share some context on, whether that's like the number of devices you've sold, the amount of revenue, the number of customers, that kind of stuff?
We launched the company publicly in April of 22. By that summer, we were doing, in the 7 figures of annual recurring revenue, and we've tripled the company every year since then. So we're past 8 figures of ARR at this point. I think in the past I'd said we're somewhere between 10 and 100 scanners. I'll say we're between 100 and 1,000 scanners. And I like to kind of stick it to orders of magnitude. But this is a company that's growing at the speed of an enterprise SaaS company. We make margins that are best in class, and we close deals really quickly, and we have a factory bolted onto the thing. So our customers have a lot of momentum. They don't return the machines. They love them. They use them. They renew their contracts. The business metrics are really world-class around Lumafield. It's something I'm really proud of, but it really pales in comparison to how excited I get by walking through a facility that, a major CPG brand or a medical device brand, is running and talking to them about the transformative impact of our technology. Companies that are moving from non-sustainable plastics to sustainable materials, having to retool their entire manufacturing supply chain globally to do this, and Neptune is making it possible for them to move faster. We have companies who are trying to, move the world from non-renewable to renewable energy products with batteries or the electric vehicles they're making. And they have critical problems in their production that Neptune is solving for them today. The same thing is true of medical devices. How do you get a medical device to market to deliver a specific drug? If you reformulate something that goes in an inhaler, you might need to change that inhaler. The speed of iteration there is, directly coupled between the drug and the delivery mechanism. The people that make the drugs, the people that make the delivery mechanism, they're not usually in the same facility. Neptune allows those people to share data to make those decisions faster, get that life-saving care to a patient more quickly. So I love the fact that we're making money. I love the fact that we're growing quickly, but I love the fact that we're really changing the lives of our customers and their customers in a really tangible, meaningful way.
Well, I know earlier we were talking about this sort of A to Z journey, and you said, I think we're on step B. I think it's fair to say maybe you're on step C or D. It feels like you've done some pretty good stuff. Well, I want to end with this, where you think about those future steps, right? Of okay, we've laid out the future state of what you can accomplish, which is really removing the humans as much as possible, building these sort of intelligent brains where you have the very best sort of manufacturing engineer in the world in your shop. What are the sort of next few milestones for you guys over the next, couple of years, or how do you think about what's most important?
Yeah, so we kind of think about the company in 3 chapters. I think chapter 1 is autonomous data capture. So I think Triton is sort of, maybe it's the beginning of the end of chapter 1, right? How do you put a system in a facility, walk away from it, and it's capturing all the data you would ever need for these other, chapters. Chapter 2 is what we call software-defined inspection. We're starting to do a little bit of chapter 2 stuff with a few of our customers. And that's what I laid out around this idea of you've captured all this data. You have some sort of, trend line that you're looking at of the information in your production capabilities. And you're seeing something that's maybe trending out of line. And SDI is sort of this predictive thing where you can say, hey, I'm seeing that the diameter of your tube is coming out of nominal. Probably your cooling system is breaking down. This is how you should change it. So closing that loop will be sort of the end of SDI. I think that'll be a few years out. So that ability to integrate all the data that's coming in off of all your production equipment to actually tweak those things. That's kind of where we're going over the next couple of years. Triton making the decisions on what the input factors are for a die-cast press or metal injection molding or plastic injection molding or composite layup, any of those sort of things that could be automated. Triton will be the driver instead of just the data feedback symbol. That's the next few years. I think further out after that, that's where we get into what we like to call internally wildly autonomous manufacturing, which is that post-human world. It's pretty out there, but it's this sense that you're not just driving the injection molding press, you're actually designing the object that's being produced by that press based on the knowledge of everything that you've ever produced in that facility. It's really taking the world's best manufacturing engineer and then using their knowledge to become the world's best design engineer. That's more than a few years out, though. That's where we're going.
I love it. Yeah. Well, Eduardo, thank you so much for sitting down to chat me through this. This has been an awesome conversation. I appreciate it.
Yeah, of course. Thanks so much.